Who can tell me the answer for this? No, with it, you can use a calculator. Give me two, rounded to two. 0.67, right? Okay. Five point, oh, 6.7 again. Okay. Tell me what the angle is. How'd you get that? Yeah, you just do inverse sine, right? Nearest degree, 27? 27 degrees? Nearest degree. So you guys, this is basically the trig that we've done so far. Okay? But what if I asked you this? We haven't seen too much of that. What do you get? You can still use a calculator. Negative. Negative 0.8. Interesting. Negative 0.5? 0.85? Okay, yeah, 2.85. That's good. Good. The tan of 312 degrees. Negative 1.11. Interesting. We're getting negatives. I wonder if it, like, what's so special about these angles? Bigger than what we've been using, right? We have gone up to the angles, although we did do a couple in sine law and cosine law where the angles were between 90 and 180. Note that one. 0.53, yet that one's positive. Huh. And if I asked you the tan of 148, the answer would be negative. And if I asked you the cosine of 312 degrees, the answer would be positive. Okay? This is one thing we're going to look at. How we deal with the trig of angles that are greater than 90 degrees and less than 360 degrees. Okay? Because we do deal with angles of those measures. We do deal with obtuse angles quite a bit, between 90 and 180. And even ones greater than 180 we can still deal with. So here's one. Oh, sorry. What was that again? Or yeah, you should know this one. 61.2. Would that make sense if you did the sine of 61.2, should you get this about? Right? Okay. I'm going to make the argument that there's another answer. And that other answer is 118.8. 118.8. If you do the sine of that, do you also get this? So that means sometimes when you try to solve trig equations, there's more than one answer. We always just did the one answer that was between 0 and 90 degrees. That's another thing we're going to talk about in the next several lessons. And finally, something we're going to talk about is don't use a calculator. Can't use a calculator. It's a half. Can't use a calculator. Root 3 over 2. Where are those numbers coming from? Holy smokes. Yeah. Right now, if you're not familiar with it, you're right. You should have no idea. Tan 45. Jeez. Nope. Nope. Yes. Okay. So no, we didn't. Okay. But that's the other thing we're going to be able to do is we're going to be able to find the sine, cos, and tan of common angles. Like these are common angles that are used. We're not going to be able to find like sine 31 degrees without a calculator. We're going to find the common ones that we don't need to use a calculator, which is helpful because when we don't use a calculator, our answers are more exact. Okay? So we've got a few things we're going to do here. To set all this up, we need to be familiar like to do trig that involves angles greater than 90 degrees and 360 degrees. That's weird because doesn't trig involve right triangles? So how do you make a right triangle out of an obtuse angle? Well, you really can't. But you can create a right triangle to use as a reference to help you find it. Okay? So to sketch angles, to deal with angles in trig, we're going to sketch them on coordinate grids. Okay? And when we graph an angle on a coordinate grid, we call that, or we call them, angles in standard position. In standard position. That means we're using a coordinate grid. I mean, you guys know how to sketch angles. You just draw two arms that connect together at one point, and then you measure the distance between them, and we write that measurement in degrees. Okay, but now we're going to use a coordinate grid. And how we use a coordinate grid, and I'm just going to show you how we draw angles in quadrant 1. One of the arms of your angle will always be the positive x-axis. Okay? We call that the initial arm. That's the arm where we start measuring from. And it will start at the origin. the second arm of the angle, which has to come out from the same point, the origin. Okay, let's say we're going to measure in quadrant 1, which means my arrow has to come out somewhere in quadrant 1. That's called the terminal arm, or the ending arm. What do we call the point that both arms of the angle start from? We call that the vertex. But when we use a coordinate grid, the vertex is always the origin. And then we measure the angle between the initial arm and the terminal arm. So we measure this angle. And often we will call this angle using the Greek symbol. Looks like a 0 with a vertical bar, theta. I'm sure some of you, yes, are familiar with it. So what we would say, this angle is in standard position in quadrant 1. Okay, I've drawn an angle on a coordinate grid in quadrant 1. What are all the possible angles measures I could draw in quadrant 1? Anywhere between 0 and 90 degrees. Okay? I mean, I could draw 0 too. And I could draw 90 too, but those are kind of special angles we'll talk about later. How would you draw one in quadrant 2? Well, the initial arm is still the same. That's where we start measuring. But we want our angle to end in quadrant 2. So we just draw the terminal arm somewhere out here. And then our angle measure is going to look like that, which we call theta. What are all the possible angle measures if it ends in quadrant 2? Between, not 0, between 0 and higher is 90, or 0 to 90 is quadrant 1. Between 90 and 180 degrees. 90 degrees and 180 degrees. Okay. It's less than 90 and greater than 0. That means I'm drawing it in quadrant 1. So these are the obtuse angles. But I can draw even more angles. Let's say I want an angle that terminates or ends in quadrant 3. Well, my initial arm still starts from the origin and is on the positive x-axis. And then I just draw my terminal arm somewhere in quadrant 3. What are all the possible angle measures I could draw in quadrant 3? Between what and what? 180 and 270. And finally, you can probably see how the pattern's developing in quadrant 4. I want to draw an angle that's really sort of bent right around. So I draw my terminal arm somewhere in quadrant 4. Be careful. Remember, this is not the angle we're talking about. This is the angle. Starting from the initial arm and going counterclockwise towards the terminal arm. And these would allow me to draw all the angles between 270 degrees and 360 degrees. Okay. So that's the start. We need to know how to draw angles on a coordinate grid. Okay? But remember, the trig that you know how to do, it has to deal with, it doesn't deal with angles that are greater than 90 and less than 360. They were always between 0 and 90. Okay? Well, we can do that, and you'll see that. Whenever I draw one of these angles, okay, on a coordinate grid, so each angle in standard position has a corresponding, what we call, reference angle. And if we call the actual angle theta, we call the reference angle theta r. Oh, sorry, I should, yeah, let me go back to that. Yeah, I'll go back to that right now. Yeah, it's basically, we write what I just talked about here. So an angle is in standard position when its initial arm is on the positive x-axis starting from the origin, and its terminal arm is somewhere in one of the 4 quadrants. And its terminal arm, doesn't look good. Is in one of the 4 quadrants. That's what it means. Okay. So when we draw angles using a coordinate grid, we actually create other angles. And we can use these angles help us to do trig. And one of these angles is called a reference angle. Okay? The reference angle, the angle between the terminal arm of the original angle theta and the nearest x-axis. So when I draw an angle on a coordinate grid, I will also create a reference angle. So, yeah, and the reference angle, like I said, which we call that, is always between 0 and 90 degrees. Which we know how to do the trig of. Okay? So I'm actually going to show, before I do quadrant 1, I'm going to show you a reference angle in quadrant 2. Because then quadrant 1 might make a little bit more sense. So let's say I draw an angle. Let's draw an angle in standard position in quadrant 2. So initial arm, terminal arm goes somewhere in this quadrant, and that's my angle. Using that definition I had above, Where's the reference angle? I said it's formed between the terminal arm of theta, so that means it's this arm as well, and the nearest x-axis. Is the positive x-axis closest to this arm, or is this one? The negative. So this would be the reference angle. In quadrant 2. And if I tell you the measure of the original angle in quadrant 2, you should be able to tell me the measure of the reference angle. Okay? If I said this angle here was 120 degrees, 120, how would you find this one? What do you think? Sorry? 180 minus 120, because these two together will always form a 180-degree angle. Excellent. So in quadrant 2, to find the reference angle, we always do 180 minus the actual angle. If we want to find the actual angle, we do 180 minus the reference angle. So if I told you that this was 20, 160, because you subtracted from 180. Okay? So you get that idea. Now let's look at quadrant 1. First of all, let's draw an angle in standard position in quadrant 1. So that's what it looks like. Where's its reference angle? The same thing. Excellent. Remember, the reference angle is the terminal arm and the nearest x-axis. So that means that the reference angle and the actual angle will always be the same. So if I said the actual angle was 55, the reference angle is 55. If the reference angle is 40, the actual angle is 40. So in this one, the reference angle will always equal the actual angle that we're dealing with. And the actual angle will always equal the reference angle. Quadrant 3. Okay, let's draw an angle in quadrant 3. So initial arm on the positive x-axis, terminal arm somewhere into quadrant 3, and that's theta. Where's the reference angle this time? Yeah, so it's one of the arms is the negative x. What's the other arm? The terminal. So notice that the reference angle actually forms part of the actual angle in quadrant 3. The question is, how do you find it? So if I said, I'll give you an angle that ends in quadrant 3, 210 degrees. If this is 210 degrees, how would you figure that out? You got to use 180. So wouldn't we go 210 minus 180? And that would leave this space. Okay? So to find the reference angle in quadrant 3, we have to take the actual angle and take 180 degrees away. Doesn't quite work the same the other way around. What if I told you the reference angle was 15? How would you find the actual angle? If I told you this was 15. Yes. You would have to take the reference angle and add 180. So it's a little bit, you got to be a little bit careful in quadrant 3. Sorry? Quadrant 4. So let's draw an angle in quadrant 4. Here's the actual angle. Where would the reference angle be? Well, here's the nearest x-axis, the positive one. Here's the terminal arm of the original. What do you notice about the reference angle and its actual angle in quadrant 4 if we added them together? What would we get? 360. So if I told you the reference angle was 30, how would you find this? Right, 360 minus this. If I told you that this was 300, you do 360 minus this and get the reference angle. So to get the reference angle in quadrant 4, we do 360 minus the actual angle. And to get the actual angle in quadrant 4, we do 360 minus the reference angle. Okay. Okay, so let's look at example 1 and example 3. I'm not going to do example 2. So you can cross that one out, example 2. Example 1 and 3 are good examples. Okay, so what we want to do, we got to do a few things here. First of all, we're given an angle. We've got to sketch it in standard position using the coordinate grid provided. We want to state what quadrant the angle terminates in and what its reference angle is. So 160, what quadrant would that go into? We always know, like for all of these, like I can do this right now for all of these. I'm a little excited there. The starting angle is the same for all of them. Quadrant 2, whereabouts? Like, would you draw it like that?
No, more closer to the line.
So you want to draw it further down? What about halfway? No, because 160 is a little more than halfway, right? So we probably want it somewhere around there. We want it more than halfway between 90 and down to 180. Okay? So that's theta is equal to 160. Do you have to be perfect? No. But if you drew the arm up here, you're not sketching it correctly. Well, we know that it's quadrant 2, because we said that at the beginning. So the only thing we have to figure out is its reference angle. 180 minus 160 gives us 20 degrees. Okay? So 305, quadrant 4, definitely. So 270 is here, 360 is here, right in the middle? A little more down, right? Yeah, not in the middle, a little more down. Yeah, sure. That'll work. So somewhere around there. Again, you don't have to be perfect, but how would you find its reference angle? 360 minus 305, which gives us 55 degrees. About 227. Quadrant 3. 227. Well, if you think about it, to find halfway in the quadrant, add 45 to the quadrant above it. So the halfway point would be 180 plus 45, 225. So it's basically halfway. Slightly down a bit, but I mean, again, we're sketching. If you go halfway, you're good. So this is theta is equal to 227 degrees. Now, quadrant 3, we got to be a little careful. Not quite. Where you could add. Yeah, like if that's what we're trying to find, right? We got to find the whole thing 227, subtract away this part 180. So 227 minus 180 is going to give us 47 degrees. Okay. Yeah, example 2 was just taking an angle and sketching all of its reference angles in the 4 different quadrants. We're not going to worry about that. Okay, so we're just going to jump to example 3. Here's you're asked to work backwards. You don't have to sketch it. Sometimes you may want to sketch it to help you, because sometimes visualizing it helps people. Okay. So 58 degrees in quadrant 3. The reference angle is 58. So again, if you want to see it, you would draw a 58-degree angle in quadrant 3. And you're trying to find this. So yes, 58 plus 180. Is equal to 238 degrees. No, this is optional. This would be the only thing. I mean, to be honest, I'd probably give this to you as a short answer question. So in quadrant 4, again, if it helps you to draw it, it's a 71-degree angle in quadrant 4. Which means, yeah, I got to find this. So theta is going to be 360 minus the reference angle of 71 degrees, which gives us 289 degrees. Okay. Okay. Now, just before I stop this, I already made a comment about this, but if you look at all the reference angles we drew, they were always between 0 and 90. Okay? And if actually you look at all the reference angles we drew to actual angles, the next step is we can create triangles, right triangles. How can I create a right triangle to help me with this angle? Use its reference angle and draw a right triangle there. Then I can do some trig. How do I use this reference angle to help me? Draw a right triangle, and that'll help me do the trig. Because we know how to use right triangles in trig. So because every reference angle is acute, I can always make a right triangle out of it. So if I can find the trig of this, I can find the relation to this. Okay, that's the next step.